All right, so in this video, lesson 3 of the hard surface module, what I want to talk about a little bit is subtraction and addition of simple shapes. So by now, most of you, or by now at least in this course, you should be familiar with basic shapes, right? Just how you can draw basic shapes in space, successfully with any perspective or any angle, whether it be cylinders, cones, boxes, whatever, right? And you've done a little bit of manipulation as well already with in the figure module with bending and twisting. And now you've also seen rounding of boxes, multiple and single rounding. And to some degree, that's a little bit of, or actually, that is a little bit of addition or subtraction that you're doing. You're either taking off a corner or adding a corner, or adding multiple corners that are rounded. So you're basically manipulating the topology of your simple shape. And so now what we're going to do next is we're going to look at how we can even add more shapes and primarily subtract or add, mesh, like literally mesh simple shapes together, right? So for instance, if we have a simple box, right, I'm just going to draw that here. I'm not warmed up yet, so I hope this is going to be fine. So we have a simple box, right? We have a simple cylinder. We have a cone. And we have, of course, a sphere. And now first what we're going to do is we're going to look at how we can just subtract simple things from these simple shapes. And so subtraction literally means that we're subtracting shapes or topology from one of these shapes. So for instance, for a box, let's say, and I'm going to use a different color, in the subtraction method, we cut out like this section. So the resulting shape would look something like this. Right? Or we still have the box fairly recognizable in a similar perspective. Right? But we're just subtracting that shape that I just cut out. Now, for instance, for the cylinder, we could not only, so if we know about the contours of a cylinder, right, it's basically, and I'm going to use a dotted line, it's always a circle, albeit in perspective, right, that acts as the contour of that cylinder. And so now what we're going to do is we're going to subtract the shape, but we're going to cut through it, like maybe slant through it, for instance, right? So, and this is where we need to be aware of our contour lines. So if I draw the profile view of this cylinder, it's basically just a box, right? Like this. And so what I'm going to do is I'm not going to cut through it completely horizontally, because that's not really going to give us any manipulations, because it's just going to give us a shorter cylinder. But I'm going to cut through it like with a slanted line, right? And now we need to figure out, okay, how does that look in perspective? And so, I can draw the setup of it, and I'm not gonna draw it like this. I'm just gonna draw it top down. So I'm gonna redraw the cylinder first, so you are kind of on the same page of where I'm trying to go with this. Right? And so now we're going to cut through this, and now we need to figure out how that is going to look. Right? And so if we draw it, the way that I drew it here, we have more of a slanted ellipse. like that, right? So we basically cut through the geometry of our shape. And now the way that we need to think about this, so if this is hard for you to do just like freehand it like this, what you need to think about is the contours that you're essentially manipulating, because that's going to be important as well when we're doing addition. So if I think about just the contour lines of this cylinder, right, so just as it being all of these dots, basically those contours, right, or those cross sections, whatever you like it to call it, right, in perspective like this. And so we are, I'm going to use even another color, we are manipulating it on different parts of the contour. So I'm going to draw some extra dotted lines here and here. So I'm basically cutting through all of these cross sections to come up with a new one, right? And so to illustrate my point a little bit better, let's say we subtract a spherical shape from the normal cylinder, right? So we're going to take the normal cylinder again, and I'm going to draw it a little bit bigger. Like this. And now from that shape, I want to basically, as if you would in 3D, create a sphere and then paste it on top and then cut out what the sphere is interacting with, right? It's in 3D they call it a Boolean, right, where you literally cut out the shape that you've established out of the other primitive. And so the way that we can do that is by thinking about what kind of intersections we create by combining the cylinder and the sphere. And so I'm gonna use yet another color, surprise, surprise. So I'm going to draw my sphere like this. Something like that. Now what I need to think about is, okay, what are the cross sections of my sphere? Right, so in essence, they probably look like this, right? So we have all of these cross sections running across that sphere, and we have the same for the cylinder, right? And so now our job as artists is to figure out where these points, where these cross sections meet each other, right? And so where we are creating these points of insertion, and we don't only for the sphere, for instance, we don't only have these vertical cross sections, we also have horizontal cross sections, right? And I'm just going to use yet another color. So we need to be very much aware of the topology of the simple shapes that we're creating in order to understand what contours are interacting with each other. And let's say that I drew like a top-down view of this, like let's say we are watching it from above, right? We would see these red cross sections interact with the blue ones, right? And the limitation would also be where like the orange cross sections hit like the edges of our cylinder. And so based on that, we are now literally already manipulating the contour, right? It's a little bit of contour manipulation. It's not like I'd show in organic form, but it's almost the same exact principle. We are manipulating the contour or these cross sections of one primitive based on how the other primitive interacts with it, right? So let's do that. So I'm just going to now construct the cylinder based on these manipulated or cut out spherical shapes, or cross sections, sorry. Now, it's going to be very hard for me to freehand this, but I hope it brings the point across. So I'm going to draw the resulting shape, so basically this shape throughout, right? And now where it ends is all going to depend on the cross sections of my sphere, both horizontally, vertically, in a y-axis, and in a z-axis, right? So, I'm just gonna think about it a little bit. So, if I zoom it out a little bit, we have the top of my cylinder, and then like where this section hits, right? This is going to be like my first cutout. And that cutout is going to depend on this blue cross section from the sphere, right? And then we're going to have another cross section downward like this, right? But because my sphere, like because these blue cross sections are basically shrinking and shrinking because the center of our sphere is the biggest, right? And then we go smaller and smaller and smaller and smaller and smaller to infinity to create that sphere, right? So it's going to be smaller on this side. So my cross section is going to run through a little bit more. And then we have that blue contour section again, right? Like this. And then like that. And then we're going to have something like this. And a smaller cross section, something like that. And then we're going to draw our resulting cylinder that is going to have like this cutout for a sphere, a little bit like this, right? And so if I redraw that to make it a little bit more clear, we would probably have something that ends up looking, I'm just going to need to think about how this works. Again, this is definitely not easy to do. But once you understand those principles a little bit better, it'll become easier. Right? So this is how that sphere can affect that cylinder. Now the sphere, again, is very hard to figure out because it's a spherical object and there's a lot of contour lines going on. But we can do the same for like when a cylinder interacts with a box, right? So let's do that. So we have a box like, I don't know, something like this, maybe a different perspective. Right. All right, and now we're going to insert a cylinder. No, we're gonna extrude a cylindrical shape out of this box, and then we need to figure out how that looks, right? And so let's see where we're gonna extrude it. Let's say I'm gonna draw a cylinder in the same perspective, of course, right? Like this. And I'm gonna completely cut out that corner of this box with that cylindrical object or primitive. So again, the thing I need to think about is how do the cross sections of my box, what do they look like? And basically they're just, you know, square shapes in perspective. Right? And then the cross sections of my cylinder are these green dots that I already indicated. Right? So now again, if we look at this in profile, so we're going to look at it like this, we can see that we have that cross section of the box, and we have the cylinder over here that's cutting through it. And so now it's our job to figure out where these points all intersect, which is a little bit easier, like I said, than the sphere. Where these points intersect and how that changes the topology and just the shape of this simple shape. Right. So if I draw the resulting shape, and let me do it again cross-section by cross-section, and then just draw the resulting shape. So I'm going to do that down here. Look, yeah, you can still see that. Okay, so it's going to be this cross-section. I'm going to write like this. And basically what I'm doing here, right, so I'm figuring out, because this is very easy, I'm figuring out what the resulting cross-section here looks like. Right, so this is the part that I'm leaving out. And so I'm basically warping that, if you know Photoshop or something, I'm basically transforming and warping it into the perspective that I've drawn here. So something like this. And then right, so these are all these cross sections that's going to make up this box. And so if I draw the resulting box, it's going to look something like this, right? So we have essentially cut out what would have been the rest of my box. And that's basically what we do with subtraction. So the main thing that you need to keep in mind is that we're using all of these primitives, like you see here, and we're combining them in simple ways or either complex ways, right? Once you, and that's something we'll look at in the contour manipulation, once you understand this with basic shapes, just like anything, we can go to more complex shapes where we cut out a very complex shape out of another complex shape. But the principle is exactly the same. We just think about which contour sections are interacting with the other ones. We figure out the points at which they intersect, and then we cut out those points. All right, so that's it for subtraction, and now let's move on to addition. All right, so for addition, it's essentially going to be easier in my opinion, because once you understand subtraction and how to cut shapes out of another one, adding them is actually just leaving the thing you've cut out with in the overall topology. So what I mean by that is, like, I could have easily just made an additional or addition technique here, where I just, instead of cutting out what this cylinder was intersecting with, I just leave the cylinder in, right? And see how that shape would look like. Now, in this case, it's fairly obvious, but we don't see where the topology changes. So I'm going to do an example where we can visibly see that going on, right? So let's say, again, we're going to use the box and cylinder example. We have a box in perspective. I'm going to use a bigger base for the box, like this. Well, we can use a little bit of a 3-point perspective if we want to. You guys should be familiar with that by now. Right, so let's have a 3-point perspective, and we're going to add now on top, right, addition, we're going to add a cylinder on top of this. Right, so I'm going to draw that cylinder in green again. And so the way I drew it here, we can still go both ways. We can either subtract the shape that the cylinder is creating from the box, or we can add this cylinder to the box. And that's what we're going to do now. And the principles are exactly the same. So same as I did with the box here, I'm going to again think about the cross sections of my box. Right? So looks something like this. All of these cross sections that we have here. Right, and they of course run through to the other side. Right, like that. And then we're also going to think about the cross sections of that cylinder. And so now again, the principle is exactly the same. Depending on where this cylinder kind of sits in space, we're going to now add this to the box. Now I'm going to move the cylinder a little bit to the back, just to prove my point when it comes to addition, right? So if you look at it again from the side, I have the cross section of the box that I'm creating, right? And I'm going to add in my cylinder here. Right. And then we're going to look at how that is actually, how that resulting shape would look like. So again, I'm going to start with my cross sections just to, hopefully give you guys a little bit of an idea what I'm trying to tell here. And then we're going to add that cylindrical shape. And so this is where we figure out where each of these cross sections interacts with that box. Right. And so the resulting shape will probably look a little bit like I'm going to draw a little bit of a different perspective. Doesn't really matter. So we know where it should end, right? Because we know our cross sections of the box. And then we know the cross section of my cylinder where it ends compared to, of course, the cross section of my box, right? So it'll end here, it'll meet here, and then it will run through, because we'll see a little bit of that cylinder. It'll intersect like this, and this will just run through the side. So if we draw it from a little bit of a different perspective, like this. We will see like the bottom of my cylinder hit the plane of that box, go up a little bit, right, and continue onward. Right. So it's gonna look a little bit like this. Right? So we're basically, what we're doing is we're adding that shape into another shape. All right, so let's do another example of maybe something a little bit more complex. Like, for instance, the face, right? I think that's a good one. So as you saw me explain in a lot of the Loomis videos in the Loomis classroom, is basically what we're doing with the even more simple shapes of the face. It's just a cylinder attached to a box, right? So it's we have a, and I'm going to do a top view. So we have a cylinder, or a sphere, I'm sorry. We have a sphere for the cranium. And then we're going to add in a box. Into the topology of this sphere. So again, we need to think about, where do these contours interact with each other, right? To give us a good indication right, like this, to give us a good indication of where everything kind of connects, right, to form a little bit more of a face, right? So, and again, like what we're doing with the box maybe, is that instead of it being a straight box like this, it's a little bit of a manipulated box, right? So a tapering box. Like that. And now we're inserting that into that sphere. So what that looks like is, we have the sphere like this. And then I'm thinking about how that box is, when I insert it into the sphere, right? How that is basically affecting its and let me think about this one for a second. So probably like this a little bit, and then like that, right? So these are like the insertion points that we can figure out based on the contour lines or the cross sections that interact with each other, and then we can figure out how this inserts into a sphere like that. And that if you know things like this, it makes it a lot easier for you to just invent things from imagination, but also just come up with interesting shapes, come up with more complex shapes, and just especially gives you more tools, to be able to figure out how to break up a lot of complex shapes. So when you look at a certain shape, you can then see how things are being added or subtracted from it in order to, come to that resulting shape. And I think that's really important and really important to understand. To give you a little bit of an example, for instance, like I have this spree bottle right here, and this is like a beautiful example of addition, right? We have a cylinder that is attached to a more spherical object, and that's inserting into a manipulated box, right? So that's basically what's going on. And so when you first look at this, you might be very intimidating on how to draw this. But if you can think about it more as being first and foremost, I'm just going to draw the simplified version of this. Has a little bit of a curve like that. I'm just going to draw it somewhat simpler than it's actually looking. Right. So this is like the top here. And then what's happening is we are inserting almost like half a sphere, right? So I'm just going to do plus half a sphere like that. All right. And that half sphere also connects to a little bit of a tapering cylinder. And now we're adding that into this basically manipulated box, right? So once we understand how these contours are intersecting with each other, we can figure out where things end and meet, and so how we can then create a more true to reference, let's say, right? So now I know, like, okay, I have the nozzle, and now we're gonna, because at this point I'm gonna intersect with one of the contour lines, probably at this point, right? With one of the contour lines of that half a sphere. So it's gonna look like this, and then instead of going straight down, it's not a cutout, right? As soon as I come across this, I'm gonna pick up the silhouette of that half sphere and connect with the bottom. So I'm going to pick up the silhouette of my half sphere. I'm going to exaggerate it a little bit for demonstration purposes. Right? And so the same is going to happen on the other side. We basically have our sphere here. Right? And so we're going to see him appear over here. And then we're going to have, of course, our cylinder. And we're going to still see a little bit of that box coming out of the other side. Okay. So, of course, this is a little bit exaggerated in terms of width. It's a little bit more narrow. Again, it's not a perfect half sphere here. It kind of also tapers in a little bit. But if you already understand how this works, Like, then making complex shapes will be so much easier for you guys. I promise, right? So again, remember, it's all about figuring out where your cross sections like literally, cross with each other, and then either removing those points from, whatever it is you're trying to, subtract from your shape, or it's adding that simple shape, but then figuring out how the new topology or how the new shape will look like based on where the cross sections meet, right? So that's it for addition and subtraction. I hope it was clear. And again, I'm going to give you some more simple assignments to start with, and then we'll go into more complex assignments. All right, and now, so for your assignment for this addition and subtraction lesson, what you're going to do is you're going to draw, it's going to be a three-parter again. You're going to draw, in part one, you're going to draw 20 subtracted shapes, right? So simple shapes where simple geometry has been subtracted, right? So a box interacting with a cylinder interacting with a box, a cutout of a sphere, like you see here. Very simple subtractions, 20 shapes. Part two, same thing, but addition, right? 20 simple primitives added to other simple primitives. You can have a little bit of fun with it and maybe, subtract a little bit and combine it, but it should be simple. Again, 20 simple primitives, interacting or being added to other simple primitives. And then for part three, what you're going to do is you're now going to combine the two, but you're going to reference anything that you can find in terms of household objects or whatever. So you're going to find 10 different things, and you don't have to copy the entire thing. If you can just find something like a part of it that has the combinations that we've been talking about, like I have here with the bottle, if you want to just draw the cutout of it and the addition of it and only draw this shape, that's completely fine. But you're going to find 10 of these examples for yourself, right? And you need to include the reference when you submit this because it's important for us to see it. But you need to do 10 of these household objects, or at least parts of it, and submit that as your third part of the assignment, right? So again, a total of 50 drawings in this one that we need to see, and we need to see the reference for the last part 3. All right? So, good luck with this, guys, and have fun.